We're now at the fourth part in this extended probability problem. If you randomly select 5 peanut M&Ms, compute the probability that none of them are blue. This is an expansion off the last problem we did, as well as off the idea of complementary events. What do I mean by that? So let's take a look. First thing we note is that we're looking at selecting 5 separate peanut M&Ms. So that's the idea of having 5 independent events going on. 5 specific M&Ms that we're calculating. And we know that because these are independent choices, we can get their probabilities by multiplying them together. So we're going to multiply 5 events together. But on top of that, we have to consider the second part, which says that we want to know what is the probability that none of them are blue. So none of them are blue. Well, none of them being blue, how could we get that occurring? Let's break it down individually a little farther. Let's focus on our first M&M. And we want this M&M to not be blue. So in other words, what would be the probability that it's not blue? Well, we have a rule for complementary events, right? If I want to know what is the probability that the M&M is not blue, I simply take 1 minus the probability that the M&M is blue, correct? Or in other words, the probability that that first M&M is not blue is just 1 minus, and then the probability that it is blue. Okay, so 23% of the M&Ms are blue, so the probability that it's blue is 0.23. The probability that it's not blue is 1 minus 0.23, or if we like, 0.77. That's the probability that the first M&M is not blue. The cool thing, though, is because we have independent events and we have a repetition going on, we're just about finished with this problem. What do I mean by that? Well, the probability that the second one is not blue is going to be the same probability that the first one's not blue. So that's going to have a probability of 0.77 as well. The third one, the same thing, right? 0.77. And the fourth one, same thing. The probability that that's not blue is 0.77. And finally, the last guy, the probability that that one is not blue is also going to be 0.77. Now, this is a series of independent events. So if I want to get the probability of that those 5 things happening, so I'm going to put the probability that all 5 are not blue is equal to the probability that the first one's not blue, the probability that the second one's not blue, right? Etc., etc., etc. So we have 5 probabilities of the M&M not being blue, but we've already set the whole scenario up. What are we doing? We're simply taking 0.77 times 0.77 times 0.77 and doing it again and doing it one more time for each of those 5 events. Or we could think of it as 0.77 to the 5th power, right? Let's whip out our calculators. And we have that 0.77 to the 5th power is approximately equal to 0.270678416. Rounding to the nearest 3 decimal places gives us that the probability that you randomly select 5 peanut M&Ms, none of which are blue, is 0.27, rounding to the nearest third decimal place is going to give us 0.271. Whew, that was a little more difficult. Used a bunch of different ideas, but I hope it makes sense. If you have any questions, please reach out. We have one more video to go, and then we're done with this problem.